Hi everyone. So today we're going to talk about a mole. So what exactly is a mole? No, it's not these furry little creatures, though they're super cute, unless they're destroying your yard. Um, but it is a counting unit. It just makes it easier for us to count a really large number. Okay, so back to it's just a number. So if we said I had a dozen eggs, then you know how many eggs do I have? I have 12, 12 eggs. If I said I had 2 dozen eggs, then I know that 2 dozen, that if 1 dozen, let's see, so if I had 2 dozen, and I know that I have 1 dozen equals 12, then 1 dozen goes in the bottom, 12 eggs goes across the top, equals 24 eggs. And yes, I know, most of y'all just did that in your heads. You know 2 times 12 is 24. However, if we get used to using the dimensional analysis, it makes our life a lot easier as we go on. So let's try the next one. So when we talk about a mole, it is also known as Avogadro's number, and it means that the number is 6.02 times 10 to the 23rd. So just to get an idea of how large that number is, it is this number right here. The 10 to the 23rd just tells me that I need to go 23 decimal points to the right from this point. So this is the number. So if we were to divide this number of pennies evenly amongst everybody on the face of the earth, if we assume 7 billion people, so that would be 7 times 10 to the ninth. So we would have 6.02 times 10 to the 23rd divided by 7 times 10 to the ninth. And that is going to equal 0.86 times 10 to the 14th, which comes out to, and then we want to divide by 100 because we're giving out pennies, so we want to turn it into dollars. So we'll divide this number by, so again, setting up our dimensional analysis, 100 pennies equals $1. So this would come out to be 0.86 times 10 to the 12th. So this is going to be 86. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. $860 billion each. So that makes us way richer than what Bill Gates is now. So that just gives you an idea of how large this number. So everybody on Earth would have $860 billion. Okay, so in terms of how many dozens of each of the following are there, if I have 1 dozen cars, well, for the steering wheel, there is 1 steering wheel in each car. So if I have 1 dozen cars, I'm going to have 1 dozen steering wheels. If I have my car has two windshield wipers, and we're only counting the front windshield, the windshield wipers. So there are 2 usually, and so it's going to have 2 dozen windshield wipers. And in my dozen cars, each car has 4 tires, and I'm not counting the spares. So each car has 4 tires, and so that is going to give me 4 dozen 4 dozen tires. Okay. And you need to be better about keeping your units than I am. We were talking about dozens. And why we want to make sure we keep our units will become more evident as we get further, but it's very important that we keep our units. If I had 3 dozen cars, how many dozens will I have of each of the following? So if 1 dozen cars has 1 dozen steering wheels, then 3 dozen is going to have 3 dozen steering wheels. The windshield wipers, if 1 dozen has 2 dozen windshield wipers, then, and the way this is going to work, 1 car equals 2 windshield wipers. So if I have 3 dozen cars, to set up my dimensional analysis, I have 1 car times 2 windshield wipers. So I have 6 dozen windshield wipers. And the car part cancels out. So for the tires, if I have, we said that 1 car has 4 tires. So we have 3 dozen cars. We said 1 car is equal to 4 tires. So 3 times 4, car cancels out, and we have 12 dozen tires. Okay, so what we need to talk about now is that when we look at these numbers, and remember, if there's nothing written here, then the coefficient is 1. I'm going to look down here too. The coefficient is 6 in this one. That number, those coefficients that we've talked about, are equal to the number of moles. So that is the number of moles. Okay, so in the first one, if we have 1 mole, how many atoms? And I think my question should have been how many moles, but we have 36. We have, or I'm sorry, we have 1 times 6. We have 6 moles, or 6 atoms if we were talking about a single molecule. Um, how many hydrogens? We have 1 mole times 12 is 12. And for oxygen, it's 1 times 6. So 6. So if I have 6 moles, if I have this coefficient here, then it's like saying I have 6 cars. So how many carbon atoms are present if it was a single molecule? Then this is telling me 6 molecules. But when we're looking at our chemical equations, that is moles. So 6 moles times the 6 carbons means, so if I know that 1 mole is 6, 1 mole of the entire sugar, 1 mole of C6H12O6 is equal to 6 moles of C6. So how many carbon are present? So we have Uh, 1 mole, we have 6 moles of C6H12O6. We know that in 1 mole of C6H12O6, I have 6 moles of C. This part cancels out, this part cancels out, and we wind up with 6 times 6 equals 12 moles of carbon. Okay, I'm going to erase this just so I can do the next one. So put it on pause, take notes if you need to. Okay, so the next part, hydrogen. I know that in 1 mole of C6H12O6, we have 12 hydrogens. So if I have 6 moles of C6H12O6, so I know that 1 mole of C6H12O6 is equal to 12 moles of hydrogen. Moles of that cancel out. So 6 times 12 is 72 moles of hydrogen. And then oxygen, again, we have 6. So just like the carbon, it's going to be 6. When you fill in the numbers, it will be done just like the carbon because we know that 1 mole of this sugar is equal to 6 moles of oxygen. Okay, so let's review real quick. The atomic number, and that just tells us how many protons. The atomic mass, this number here, and for most of our purposes, you can round this to the nearest whole number. If rounding it to the nearest whole number won't work, I will let you know. But for the most part, I believe almost everything we do, you can round it to the nearest whole number, and it will make our math just a little bit easier. So our molar mass is equal to 6.023, or 6.02 times 10 to the 23rd, which is equal to 1 mole. So what I know is that if I have 16 grams of this element, 16 grams of oxygen, I am going to have 1 mole. It also means that I'm going to have this number, 6.02 times 10 to the 23rd, number of atoms. So 6.02 times 10 to the 20, so that tells me how much that number of atoms is going to mass out to. So if I have 1 mole of oxygen, then the mass is going to be 16 grams. Like I said, it is okay to round up. It will make our math much easier and much more tolerable. When we start using these kind of decimal numbers, it gets very tedious. Now, 1 mole of O2, Okay, so we said that 1 mole of oxygen is equal to 16 grams, because that is what our molar mass or our atomic mass tells us. So 1 mole of oxygen is equal to 16 grams. However, this has 1 mole of O2 has two has two oxygens. Hang on, okay, so I was trying to make this harder on myself than I needed to. So we need to get our molar mass of our atom, of the complete atom. So oxygen, there are 2 of them. The molar mass is 16. So the molar mass of O2 is 32 grams. So if I have 1 mole of O2, so 1 mole of O2 is equal to 32 grams. So 1 times 32 is 32 grams. Moles of O2 cancel out. Okay, and the next one. Oh, we just did all that. Oh, no, we didn't. So I left some of that information there. I left some of this information here. So, but now we're going to go the other way. 32 grams of O2 has how many moles? So this one, we said that 1 mole of O2 is equal to 32 grams. And we did that last time. So this one, we have 32 grams of O2. And we have 32 grams of O2 and equals 1 mole of O2. 32 counts, so it equals 1 mole. So the next one says 80 grams of O2. So we put the 80 grams. It is our known. We always put what our known first. Our unknown should be at the top, 80 grams of O2. So we're trying to get rid of grams and get to moles. So 1 mole goes at the top, and 32 grams goes on the bottom, because we want to be able to cancel out the grams of O2. So 80 divided by 32 equals 2.5. Okay, so there's going to be some practice problems. If you have any questions, please feel free to ask. Thank you and have a great day.